Now, let's get a closer look.
The gallbladder is a muscular, pear-shaped storage sac attached to the lower surface of the liver. In addition to being able to store about 50 milliliters of bile, it also concentrates the bile before secreting it into the duodenum after meals. Bile is produced by the liver and secreted into a network of intrahepatic bile ducts before reaching the common hepatic duct. The common hepatic duct then connects with the cystic duct, which allows the bile to flow into the gallbladder. When the gallbladder contracts, bile is pushed back out of the gallbladder through the cystic duct and flows into the common bile duct, which joins with the main pancreatic duct before emptying into the duodenum. Focusing on the gallbladder at low magnification, the gallbladder wall has three main layers: the inner mucosa, tunica muscularis, and its outer layer of connective tissue called the external adventitia or serosa. If we first take a closer look at the mucosa, we can see that the mucosa has many mucosal folds, or ruga, but they're not long enough to be considered villi. Some of the folds of the mucosa are deep enough to form the appearance of cross bridges when seen under a microscope, such as the two in this image. If we increase the magnification to 40 times, we can see that the mucosal epithelium is lined with simple columnar cells that are overlying the lamina propria, which contains dense, irregular connective tissue, many immune cells, and small capillaries. The gallbladder's mucosal folds may look similar to portions of the intestine, but can be distinguished by the gallbladder's lack of intestinal crypts at the base of the mucosal folds. In the bottom of this image, we can see a portion of the next layer underneath the mucosa, called the tunica muscularis. Here, we can see more of the tunica muscularis, or the muscular layer of the gallbladder. The muscles in this layer are grouped in bundles of smooth muscle, but they are actually randomly oriented. The contraction of these muscles results in the emptying of the gallbladder. At the top of this image is the mucosa, and underneath the tunica muscularis is the gallbladder's outer layer of connective tissue. The thick outer layer of connective tissue is different depending on the section of the gallbladder we're looking at. The portion of the gallbladder that's attached to the liver has an external adventitia that's meant to attach the gallbladder to the liver, which is why it's mainly composed of dense, irregular connective tissue. The portion of the gallbladder that's not attached to the liver is covered by an external layer called the external serosa. If we look at a section of the serosa, we can see that it's primarily made up of loose and irregular connective tissue with an outer membrane of simple squamous cells called mesothelium. In comparison to the adventitia, the external serosa will also have a higher number of other structures present within the connective tissue as well, such as large blood vessels, adipocytes, and lymphatic vessels. All right, as a quick recap, the gallbladder is a muscular, pear-shaped organ that stores, concentrates, and then releases bile into the duodenum. It has three main layers: the mucosa, tunica muscularis, and an outer layer of connective tissue. The mucosa is highly folded with cross bridges and a simple columnar epithelium. The muscular layer is made of bundles of smooth muscles that are randomly oriented, and the outer layer of connective tissue is referred to as either the adventitia or the serosa. The adventitia is found in the portions of the gallbladder attached to the liver and consists of dense connective tissue. The serosa is found in the portions not attached to the liver and consists of loose connective tissue and an outer mesothelium of simple squamous cells.